Homeostasis. Homeostasis. Many animals maintain relatively constant conditions in their internal environment through a process known as homeostasis. Even as external conditions fluctuate widely, homeostatic mechanisms regulate internal conditions to keep systems functioning at their optimum. There are two types of feedback systems that regulate homeostasis. They are negative feedback and positive feedback. Negative feedback system. Most of the control mechanisms of homeostasis are based on negative feedback. Negative feedback is when a change in a variable triggers mechanisms that reverse that change. The thermostat in your house works this way. When it registers that it has gotten too cold, the thermostat sends a signal to the furnace to turn on and raise the temperature in the house. The change, cold temperature, triggers mechanisms to reverse it, make it warm. But also keep in mind that the opposite is true. If the house gets too warm, then the thermostat will send a signal to turn the furnace off. So, negative feedback mechanisms, they act in reverse to what the stimulus is. It doesn't mean that they always act in a way that's going negative or like lower in number, lower in temperature. It's just whatever is opposite of the original stimulus. Negative feedback system. On a sunny day, your internal temperature rises above the set point, the normal range. This is detected by sensors in the skin. Sensors send this information to the brain, the control center, where it is processed into a response. Blood vessels dilate, and your body begins to sweat. This allows your temperature to return to the set point. This is negative feedback because the response reverses the stimulus. In this case, it was hot outside, your body decided it had to cool down and avoid getting too hot. The opposite would be true as well. If it was a cold day out, your body would need to warm up to avoid getting too cold. Negative feedback system. If there is a stimulus, such as sunshine raising the internal body temperature above a set point, receptors in the skin will detect that and send information to be integrated by the control center. The control center will direct a response. In this case, blood vessels will dilate and the body will begin to sweat. And then the body temperature will go back down to the set point, which in the case of humans, it's an internal body temperature of 98.6 degrees Fahrenheit. Glucagon and insulin participate in a negative feedback loop. Maintaining a stable blood glucose level is a crucial type of homeostasis. When blood glucose is low, the pancreas releases glucagon, which induces the liver to break down stored glycogen and release glucose into the blood. When blood glucose is high, the pancreas produces insulin, which causes liver cells to take up glucose from the blood and build glycogen molecules for storage. Glucagon and insulin participate in a negative feedback loop. In this diagram, we see that low blood sugar will stimulate the pancreas to secrete glucagon, which in turn promotes glycogen breakdown, causing glucose to be put back into the blood. So that's negative feedback because we are opposing that stimulus. The blood sugar was low, that was a stimulus. Now we're putting sugar back into the blood. The opposite happens with high blood sugar. High blood sugar stimulates the pancreas to produce insulin. The insulin signal is delivered to build up glycogen again. And then that's going to lower the blood sugar, which again is negative feedback because we are opposing that stimulus, which in this case was the high blood sugar. So glucagon and insulin are antagonist hormones. The effect of one causes the stimulus for another. Positive feedback system. A positive feedback system is one in which homeostasis is regulated by magnifying a change instead of reversing it. The inflammatory response is an example of positive feedback. When injury or infection occurs, histamines, small signal molecules, are released at the site of damage. Histamines cause local blood vessels to dilate. Blood flow is increased, which causes redness and swelling. The redness and swelling, in turn, causes more histamines to be released. Positive feedback system. When more histamines are released, the positive feedback cycle restarts and is continually amplified until all pathogens are destroyed. When that signal is removed, the positive feedback loop stops and homeostasis is restored. Thermoregulation. Animals must regulate how they exchange heat with their environment. Different types of animals have different ways of regulating body heat. Animals fit into one of two categories: ectotherms or endotherms. Ectotherms. Ectotherms are cold-blooded animals. Most of their heat energy escapes into the environment, so their body temperature is close to that of their surroundings. Activity of these animals is drastically affected by temperature changes in their environment. When outside temperatures rise, they become more active. When outside temperatures drop, they become more sluggish in their activity. The disadvantage here is that if danger comes and they're feeling sluggish, they can't run away or escape. But what they can do is they could hibernate a lot easier. If a winter comes and they live in a northern climate, they could just very much stay inactive, like the way fish do underneath a frozen lake. Endotherms. Endotherms are the warm-blooded animals, such as mammals and birds. These animals have evolved homeostatic mechanisms that allow them to use the heat they generate. They have adaptations, such as hair, fur, feathers, and fat, that help prevent heat loss. They maintain constant body temperatures that are higher than their environment. A polar bear's skin is actually black, although they're covered by fur that is clear and appears to be white. The black color of their skin absorbs all the colors of sunlight, and by doing this, they absorb more heat energy, and this also helps to keep their body warm in addition to the fur and the fat that they have.